Okay, we're starting algebra chapter, lesson 5, algebraic expressions. Now, when I look at just the algebra expressions, just that word by definition, it's very simple. All it is, and the only difference between what we know and what is coming, is that we already know about math and a bunch of numbers. Just ignore this here. We know that math is always involving a bunch of numbers, and we know so far in our math skills that we also incorporate the operations. Now remember, the operations just add, subtract, multiply, or divide. Really the only thing that we're actually putting into your math skills is really the letters. And we will talk about letters because the real word for letters when we talk about algebra, math, vocabulary is called a variable. Now, for example, if I use this up top, 2x plus 5, as an example, well, I know that I have a bunch of numbers, right? 5 and 2. I know that I can have also operations. If I look at my operations in this example, there's some multiplying happening, and there's definitely adding happening in this question. And very straightforward would be, obviously, my letter would be the variable x in this question. That's all it is. We're just adding the variable because we don't know what it is. And for this chapter, that would be our final answer, 2x plus 5. In this chapter, we really want to make everything as small as possible. We are simplifying, we are not solving. So on this page, really, you have to know just definition. So algebraic expression, okay, made up of a bunch of numbers, operations, and letters. The next one would be a symbol or a letter. It's really just the fancy word of variable that goes with it. Then we have term, and when we look at terms, we look at part that makes up an algebraic expression. It can be composed of, I know this looks really weird here, but this is from my smartboard stuff and it kind of mixes itself up here. Numbers only. So for example, a term, a piece of algebra could just be like a +2, or it could also be a negative fraction, or it could be also a decimal. Just numbers. Also, a term could be made up of only variables, which is, let's say, an x or a k or an a. It could also be, let's say, a, b, c all stuck together. Then you also have a combination, which would be a piece of algebra. For example, combining a number with a variable stuck together. So either you have the number and variable stuck together like this, or you have a bunch of letters just by themselves like these ones here, or you just have numbers itself. So if you compare that to my expression on the top of the page again, right, 2x plus 5, I have a number by itself here and I have a combo here. I could also have a variable by itself, but in this question I don't have one. Next thing, mine's hiding here a little bit, but on your paper you can see it. A term only with a number is called a constant term. So I want you guys to highlight this constant term underneath. That just means it's a number all by itself, nothing else. So like my examples here would be a 2, a -0.5, it could be a +5, it could be a -0.72, a number by itself. It never changes. That's why it's called a constant. It never changes. Next word, coefficient, is really just the number in front of the variable or variables of a term. So it's just the number in front. So for example, if I have this expression, my constant in this question would be simply the 2 is a coefficient, and the 5, but be careful, you always look at that sign in front. If it's a plus or a minus, a positive or negative, it goes together. So in this case, 2 is a constant and -5 is a constant for the y. Like terms are our most crucial part of algebra. That's what you're going to be adding and subtracting, like terms. My fancy word for that is just twins. They look exactly the same. So for example, 2 or more terms are called like terms if they have the same variable, easy, raised to the same exponent. So for example, if I have an x, and let's say it happens to be 7x, and here I have 6x, these are like terms because they're perfectly an x and an x. And when they talk about same exponents here, they're just talking about this. Let's say I have x squared, and I have x squared also. These are perfectly the same. They're twins. You could also have a combination. Let's say, I don't know, I'm going to do fractions. Negative ab squared. That can go with 7ab squared as long as this is perfectly the same. ab squared with ab squared. It has to be the exact same match. Variable and exponents, the powers. When we look at constants, numbers by themselves, they're just numbers. They're like terms. They go together. So for example, your 2, your negative half, your negative 7, those you can actually just put them all together. They're like terms. Constants. Order of algebra. So I'm not, remember if you're on your paper, you have this written down, but if you want to put things in order. So the top of the page, guys, is just like you said, your definitions, okay? So algebraic expression, variable, term, constant, coefficient, like terms. So those are words you just have to know if I ask you the parts of an algebraic expression and where you can just actually point to them or pick them out. Order of expressions means how would you write it in nice, clean algebra as a final answer. That's what I always pick on, is clean algebra, okay? So in my clean algebra here, I would put the number first. This all means multiplying all together, right? All these brackets means multiplication. I don't need the brackets. I can just stick everything together. So your number goes first, which is a coefficient. Then you just rewrite everything in alphabetical order. So really your answer would be 5ABC. You should not be putting even dots at this point, okay? It should be nothing at all. So remember, you want it as clean as possible, no brackets, no spaces, nothing there. That is one term. For terms also, like terms, and the word terms up here, where's your terms? I'll talk about that more in class, but if we're talking about terms, for example, here there are 4 terms. This is one term. And my trick for that is that there's no adding, there's no pluses or minuses here. It's just 5ABC. Where here you have a -2, a plus 5x, a minus plus. So you actually, anything that's separated by pluses and minuses are terms. So here when I want to rewrite this, I want to write everything in alphabetical order with the variables first. So 5x, I don't have to put that plus in the front. It's the beginning of my sentence, my expression. And then I'm going to put y next, plus 3y minus 2z. And then I have a minus 2. The constant goes at the end. So I do want to emphasize that. Constant at the end. Constant goes at the end. This is not the same. This is a coefficient. Coefficient. I'm looking at my spelling. C-I-E-N-T. So a coefficient goes in front of all the variables. A number by itself, a constant, would go at the end of an expression. Next page. My last definition for this lesson is monomial. That just means that you are talking about an expression that consists of only one term. We already talked about terms. We just did that, right? That means it could be a number by itself, positive or negative, doesn't really matter. It could be a fraction or decimal. It could be a letter by itself. It can be a combination of letters together, or it can actually be a number with variables. So those are all the different kinds of terms there are. So let's pick on the degree of a monomial. So a monomial is just one term. The degree is super easy. The only thing you have to really do here is add if you need to. So for one variable, same as the exponent. So if I'm asking you, what degree, okay, in the question. So what degree is this binomial? For example, if it's only one variable. So let's say my answer, this would be my question. I really am only looking at that one. It's telling you same as exponent. So you're only looking at this. So your answer would be 5th degree or 5 degrees. Careful, if it just says this, 5a. It's not 0 because really this is a little 1 on there. So your answer here would be 1st degree or 1 degree. Then it says, what if the term has more than one variable sucked together? So then we just say sum of the exponents of all its variables. Oh, no problem. So let's say I have an expression that looks like this. And I have, this is a 2, nothing on the y, and that's a 3. So what they're telling you here is add them all up. Easy. So here, I'm going to add up the 2, the 3, and be careful, you have a little 1 there. So this would be 6 degrees for this one term. So you just add up all the exponents on top. For a constant, remember, a constant is a number by itself, so it could be anything. My trick is there's no variable, there's 0 variables. No or 0 variable. So therefore your answer is 0 degrees.